Okay, is my screen visible to all of you? Am I audible to all of you?
Yes, sir. Yes, sir.
Okay. Okay, thank you very much for your feedback. Okay. Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Welcome to CE 409 Steel Structures. My name is Muhammad Wasim. I am working as an associate professor at Department of Civil Engineering since 2020, February 2020. Okay, I joined this department in February 2020. Okay, I will be your teacher for the steel structure in this semester. Okay, some of my introduction. So I did my bachelor's in civil engineering in 2005. Then I did my master's in structural engineering from this university in 2010. And in 2016, I completed my PhD in structural earthquake engineering from Italy. Okay, this is just a brief introduction about myself. Okay, now steel structures, the lecture slides are jointly developed by myself and Dr. Muhammad Fahad, who is teaching this course to section A and section D and E. Okay, so in this slide, you will see the contact, or you can find my contact details. Okay, my email is also there. So my office is located at the first floor of academic block. Okay, at the Department of Civil Engineering. Okay. So you will also see the contact detail of Dr. Mohammad Fahad, but this is not relevant in our class. So this is for his sections, okay, because we are using the same slides. So the course information, like it's a 3 credit hour course. So, and there are no prerequisites to this course as well, okay. So this is just showing the details of this course, okay, what we will be going through in this semester together. Okay, now when we look at the OB contents of this course, so there is a specific aim of this course. That aim is to develop in the students the acceptance that steel can be also used as structural material. Okay, like other than the reinforced concrete, the steel can be also used as structural material. And at the same time, the aim states that we have to develop in the students the ability to design the various structural members of a steel structural system, such as beams and columns and tension members, connections. So this is the aim. Like the aim is that we should develop acceptance about using the steel as a structural material in the students, and also to develop the ability in students to design the various structural member of a steel structural system. So when we look at the CLOs, like there are 3 course learning objectives to this course. The first objective is about the description of the models and theories which are suitable for the analysis and design of steel structural members. The second is the develop the in the students the analysis ability to carry out to do the analysis of steel structural members under axial flexure, shear, and also to analyze the connections under axial loads. The third course learning objective of this course is to do the design of steel structure members under axial flexure, shear, and also the connections, design of connection under axial loads. So this is some introduction about the OB content of your course, like what is the aim and how many are the CLOs. Okay. Now, aim, one thing you should note down from this slide is that in this course we will be focusing on the design analysis of an individual steel members. So we will not look at the steel structure building as a whole. Okay, so in this course we will be doing analysis and design of individual steel structural members, such as beams, compression members, tension members, connections, and yes, plate girders. Okay, so this was all about your course regarding to your OB content. So in this slide, you will find the assessment details, activities related to this course. So there are three categories. First is the sessional activities, which comprises of assignments, quizzes, and a complex engineering problem. So assignments, there will be 3 assignments, there will be 3 quizzes. So I have not distributed the assignment and quizzes according to the class, but hopefully in the 3rd class you will get the first quiz. And the percentage weightage of this assignment, quizzes, and complex engineering problem will be 20%. And there will be a midterm in this course that it will carry 30% of the marks, and there will be a final term which will carry about 50% of the marks. Okay, this distribution is tentative distribution. Of course, it is coupled with the direction and policies of the coordinator office. Okay, they are subject to change based on the recommendation or direction of the coordinator office. So the topics which we will cover in this course are mentioned in this slide. Like, first, today we will have an introduction to steel structures. Then we will talk about the design philosophies, like which different philosophies we can use for the design of steel structures. So we will discuss in the next class. That the philosophies are the allowable stress design and load resistance factor design. So we'll go through those philosophies, and then we will shift our focus to the connections. The connections, there will be 2 types of connections we will discuss. We will discuss first the bolted connection, then after that we will discuss the welded connection. And once we are done with the connections, we will shift to the analysis and design of tension members. And then after that to the design of individual compression members. Then we will also be discussing the column base plates, and then we will discuss the beams, the composite beams, and lastly we will discuss the plate girders. Okay, now this is all about the contents of this course, what we will be covering in this semester, hopefully. So the books, you can refer to any one of the books which are shown on this slide. You can see there are 3 books. The first book is by Sigwai, and the 5th edition. So I would recommend you, or I will stick to the first book, which is the steel design. But you can consult the design of steel structure by Gallard as well. Okay, the 3rd edition. So this book is available in your library. Okay, there are good number of books. You can pick book from, or select or issue your book from the library. Then there is a structural steel design book by John McCormick. Okay, so you can find that book on the internet, but I have uploaded the steel design by William Sigwai book in your class. You have downloaded that book. So today's lecture is concerned, or it will be targeting the chapter number 1 of the this Sigwai book. And why I suggest that we should use the Sigwai book is that this is based on the most updated knowledge or information in steel structures. Okay, the Gallard book was published in 1994, and after that I guess, according to my knowledge, this book has not been revised. Okay, but things have changed from 1994. The codes, we will see that we will use an extensive use of a specification or manual we call AISC manual. Okay, the Gallard refers to the 2nd version of that manual, but nowadays we have the 15th version of that manual. Okay, so that's why we will stick to this book. Okay, I will stick to that book, but basically the information is the same, so you can consult any one of these books. Okay, as I told you that we will be focusing, one thing I missed out on is that our focus will be the design of individual steel structure members in buildings. Okay, we will not talk about the bridges. Okay, and in order to carry out the steel structure design, we must have a manual or specification. That manual is, we call the AISC manual. Okay, now in the slide you will see that there is a 2nd edition of AISC, which is called load and resistance factor design. But as I told you that nowadays we have that 15th edition of this manual. So things have been updating ever since 1990s. Okay, so we will not use this manual, but you can use most of the things are similar in these manuals. But I have a soft copy of that, I think the 12th edition, and I will upload in that in your classroom as well. Okay, just to I was just wanted to inform you why we wanted to shift from Gellert, or why we have to Segway book, and what manual or specification we will be using for design of steel structure members. So the thing is that without a manual, you cannot carry out, or you cannot do the design of steel structures, because in this manual you find a lot of information about the structural shapes, which we are going to discuss in this class. And there are different materials, there are different design aids you can take help from while designing these members. Okay, so that's why manual is very important in this course. Okay, so this brings us to the today's lecture. Okay, now today is just an introduction to steel structures, and basically when I try to deliver a course or lecture, so I set some outcomes of this lecture, or objectives of this lecture. The first objective for today's lecture, which I perceive that we should introduce to you, that what is the design process in steel structures, and are the different steel material. Okay, steel is an alloy. What are the different steel materials which you can opt for the design? Okay, like we have some designated steels, like you will see that A36, A992. Okay, so what are those materials, steel materials? Okay, so we will talk about their behavior as well by looking at their stress strain behavior graphs. Okay, then we will talk about the different structural shapes. Okay, like in the reinforced concrete design, you might have seen that you either design a T-beam, or you either design a rectangular beam. But in steel structures, you have to use different structural shapes. Those shapes can be wide flange sections, there can be angles, they can be channels, they can be T's. So I will introduce, or we will talk about those shapes in the class. Then finally, we have to, in order to design buildings, you need a code. Okay, what were the different codes which were used in the US? Okay, and what is the currently most active code in the US, and what is the status of the code in terms of Pakistan, like what code is being followed. Okay, then we will talk about the difference between the building code and specification. A specification, as I told you, without specification means reference manual. Okay, what is the difference between the them? So these are the some of the outcomes which I have set for this lecture. Okay, at the end of the lecture we should accomplish all of them. So as far as today's lecture content goes, so we will talk about the structural design process. Basically this design process and the design process for reinforced concrete design is similar. Then we will talk about building codes. What are we called building codes? What are the examples? What are different building codes which are being followed? Then we will talk about the design specification. Then we will talk about the structural steel material. So we will talk about their behavior by looking at their stress and strain curves. Then we will talk about the standard cross-sectional shapes, which you will be using for design of your member while selecting them. Okay, now first is the structural design. Okay, structural design means the overall proportioning of structural resisting system. Okay, like you know that whenever you architect give you a plane. Okay, so it's a building plane. So building can be subjected to different kind of loads during their lifetime. Like we design building for 50 years, and for 50 years, so we have to come up with a structural system. Okay, those structural system consist of columns, beams, girders, and eventually in order to transfer the loads, we also go for a supporting system of the foundation. And then in order to proportion the structural cross-sectional members, like there are loads which are acting on a building, and those loads are transformed to the ground through columns, beams. Now, what are their cross section? You know that we have to keep the resistance of individual members with greater then the applied load effects, okay, and that is accomplished through using area or cross-sectional area together with the material. So in structural design, we do the overall we devise a structural system which consists of column, beams, and foundations, and we also proportion the individual structural members based on the resistance which they derive from cross-sectional area and the material. Okay. Now, first, when we talk about structural design, before the structural design, we have a phase which we call the functional design or the functional planning. And that functional planning, you can say that it's a conceptual planning of the building. In that, what you do the what should be the sizes of the rooms, where should be the openings, like where should be the how much wide should be the corridor, how many stories should be in there in your building. And this functional planning is mostly, or nowadays it is carried out or done by an architect. When this functional planning is, and also the architect take cares about the aesthetics of your building, like how your building should look like. Okay. Now, once the functional planning is done, that is handed over to a structural engineer. Now, the structural engineer has to devise a structural system consisting of different structural members, okay, in order to transfer or resist the applied loading during the lifetime of the building. Okay. Now we will go to the design process, and there are different phases in design process. As I discussed, that the first phase in the design process is the functional planning. Okay, functional planning, as I already explained, that let's take an example of this academic block, like what is meant by for academic block, like what is meant by functional planning when for this academic block, like what should be the sizes of the rooms, where should be the windows located, where will the corridor will be located, how many stories will be there in this academic block. So this is called functional planning, and this is functional planning is, we can call it the development of a plan that will enable the structure to fulfill effectively the purpose for which it is built. Okay. So this is done by an architect, and once you are finished, or you finish with the functional planning, the plan is handed over to a structural engineer. And structural engineering, just let me go for the pen, okay? I'm sorry. So in the second step in the design process is the structural scheme. And what is structural scheme? Structural scheme is a division. It's about devising a structural system which consists of columns, beams, girders, slabs. Okay, so this is done by a structural engineer. Okay, now it's the structural engineer who decides the overall proportioning of this plan. Like overall proportioning means that where the columns should be located, where the beams should be located, how much will be the sizes of the beams, and how much will be the sizes of the column. Okay, once this planning is after the functional planning, when the structural system is devised by a structural engineer, so this is a continuation of that structural system. So like you use beams, you use compression members, so you can see the different components, and you might be familiar with these components because you have studied that concrete design. So the loads are transferred from beams to columns, and then to the base plate, and finally to the ground. Okay, this is just a 3D view of that structural system, okay, I was talking about. Then after that, once you have done with the functional planning and the structural scheme, where's the structural scheme? Yes. Then you have to come up with the individual sizing of the members. And in this slide, you will be seeing that there are some guidelines to select the individual beam members. Like, for example, if the length to depth ratio of a member should be less or equal to 800 by Fy. For example, you want to select a beam, okay, and you have to decide about the depth of that beam. Guideline, okay, to this will be a rough estimate. Like we have seen that in case of simply supported or one and continuous, we always take a start from h by 20 or h by 16, if you remember. Okay, like this. Yeah, I'm sorry for my drawing. So this is, you have to do the individual member sizing for beams, and then you have to use some criteria to select the cross section of for the beams. Okay, and for the columns. Now you have to do strength to capacity consideration. For example, this slide is showing the strength capacity consideration for beams, like the load is coming from slab to beams. Okay, and in the steel structure you will see that this is a bit different than conventional steel concrete design, that you also have to brace your beams and columns. Okay, in steel structures, your beams are susceptible to not only fail in the material failure, but they can also fail due to this, there will be due to the stability. And there are two types of failures. One is we call the local stability failure, one is the global stability failure. And once you have that you want to avoid that stability failure, you have to provide some bracing. Like for example, there are two beams. Okay, now this beam, this is called X section or wide flange section, and it is susceptible to this translation when it is loaded. Okay, so it is also susceptible to some twisting, we call lateral torsional buckling. Okay, so in order to cater or in order to avoid those stability failures, these beams are braced like this. Okay, once the brace length is more, the demand in your structure will be very less. Okay, similarly for a column member, they are cylinder, so they can fail in the stability as well. Okay, like this is a column. Okay, I'm sorry अगर drawing मेरी अच्छी नहीं है तो. So there are two columns and they, for example, they are failing in stability, then you can brace them. If the brace length is more, there will be less demand in your structure. Okay, is that clear to all of you? Any questions from your side up till now? कोई सवाल है आपका?
No, sir.
समझ आ रही है कि बिल्कुल समझ नहीं आ रही आपको?
Excuse me, sir.
जी जी
सर जब हम ब्रेसिंग करते हैं सर, तो हमारी भी सर कोई रिक्वायरमेंट होती है, क्योंकि ब्रेसिंग से सर हमारे साथ तो हाई एरिया फिल हो जाती है ना सर. तो अगर हमारे पास एरिया का वो इधर हम कहें कि हम इधर ब्रेसिंग प्रोवाइड नहीं कर सकते, तो इसके लिए अलग अल्टरनेटिव क्या होगा सर फिर?
You have to use a larger cross section.
ओके सर, ठीक सर.
But you have to do this bracing. Okay, without bracing, like what I have studied in steel structure, you have to do this bracing. लेकिन ये है कि these beams are located at a very high height बहुत ज़्यादा होती है, and bracing you have to do because these beams are susceptible to twisting and translation. जब
Yes, sir.
when they are loaded, so they are susceptible to this translation. And in order to आप reinforced concrete design में आप क्या करते हैं? What you do? You don't want to have a bar slip. That's why you provide those hooks. अगर वो hooks आप provide नहीं करेंगे तो हो सकता है कि कि उसकी फुल जो यील्ड स्ट्रेस है उसमें डेवलप होने से पहले ही वो फेल हो जाए, बार स्लिप का प्रॉब्लम आपके पास आ जाए. So that's why you use deform bars and you provide those hooks. But I wanted to highlight that this is an important aspect in steel structure, bracing. You have to do bracing. Like for example, the height is not that much. You will have to check first. Is my member is failing in local buckling? Is my member is failing in translation? If it is not failing, if the load is not that much, you don't have to do the pressing. Is that clear to you now?
Yes, sir.
Okay. Now, similarly, if we proceed that, then we come to the column. In column, what happens that load comes to the from the slab and it is like transferred to the ground to these vertical members. Okay. you also have to do proportioning of these columns. And one other aspect, as I have highlighted in the case of beams, that not only it can fail as in material failure, it can also fail in stability. If it is there is a stability issue in your beams, you have to do the bracing. Okay. So after that, we have this step we call the structure analysis, and you can see that this is a 3D view. This is a model of that building which has been generated in a software. You can use SAP, or you can use ETAP software to come up with this model. Okay. Once you do the structure analysis, you compute the demand in your members. Once you know the demand, okay, then you have to do the design review. Okay, design review means that the demand on your structural member should be less than the resistance which is provided by that member, and that resistance is derived from the cross-sectional area and the material strength. Okay, so the material strength should be the resistance in the member against the demand should be more, and you should also keep a margin of safety in that. Okay, like there, if the demand is 2, the capacity or the resistance which member is providing, it should be 4. Okay, so you will keep a factor of safety because you are not sure about the build loads as well. Okay, so you have to take care of that. Okay, then finally, once you are done with this process, you make cost estimation for various tentative structural layouts. Like if I use this member, I place it there. Okay, how economical it is. Okay, am I satisfying the strength criteria? Like my building is able to resist all the loads. Okay, but the thing is that in case of steel structures, you have to use the objective of your objective should be that you should use minimum amount of steel. And this is we call in steel structure, you have to use members which have light weights. Okay, if the weight of the member is more, the cost of the member will be more. Okay, now, this cost estimation not only depends upon the structural members, but it is also controlled by the labor, which they will be fabricating this your steel structure building or steel structure. So it is the skill labor, the cost of the skilled labor is also important because the scale labor cost in steel structure is very high. Okay, so you have to do all this consideration. You will also look at the availability of the steel material. For example, you are making a building in Karachi. In Karachi, you have a lot of factories, so they are producing the steel, so there is no issue. For example, you are building a steel structure in Miranshah or some other area which is very far away, so you will take care of that the material which I'm using is that available in the market. It will be not that costly if you are going to use that in your design or in your structure. Okay, so at the end of the design process, you give away these drawings. These are structurals and architectural drawings. So this was the whole structure design process. Any question from your side? Oh, all is clear. Oh, none is clear.
क्लियर सर।
आप लोग वाकई समझ रहे हैं कि नहीं? मैं थोड़ा सा कनेक्ट हुआ है कि मैं थोड़ा सा लगे कि मैं डिस्कनेक्ट इस तरह का हो गया हूँ क्लास से। और डिस्कनेक्ट होने का मतलब ये नहीं है कि मैं इंटरनेट से डिस्कनेक्ट हो गया। सो देयर शुड बी ऑलवेज कनेक्शन बिटवीन अ टीचर एंड स्टूडेंट्स ना। तो ठीक है, you know that this process is, you have been familiar with this process, but what I wanted to highlight that, like in steel structure, you will use different shapes. Okay, you will not use those rectangular or T sections. So stability is also an issue. Okay, in steel structures, it was not that issue aap logon ne they were in reinforced concrete design, but in steel structures it matters. Okay, so once we are done with the design process, so this is the philosophy of structural design, that the resistance of material which it derives from the cross-sectional area and the material strength. And when we talk about material strength in steel structures, it means the yield strength and the ultimate strength. Okay. Now, the strength of the material or the resistance of the material should be always greater or at least equal to the effects of the applied loads. Now, this is a very important and basic equation, but there is a limit, there is a constraint on this equation that you should evaluate the resistance, for example, resistance against compressive force, against the effects or stresses which are produced by compressive forces. You cannot evaluate the tensile resistance against the compressive load effects. So basically, you have to evaluate or use this equation for the same loads. Okay. Now, in this structural design, we will talk about sometime there will be the terms which have the same meanings like resistance, capacity, and strength. They means the same thing. Okay. And the terms like demand, stress, loads, they are the same things. They were used to express the effect of the loads. Okay. So in structural design, you have to satisfy a limit states as well. Okay. A limit state is a condition. Okay. Limit state. Okay. This limit state. A limit state is a condition beyond which a structural system or structural component ceases to fulfill the function for which it has been designed. Okay. So limit state, you have to satisfy the limit state in structural design in LRFD. Okay. There are three types of limit states. We call them strength limit state, serviceability limit state, and special limit state. Strength limit state is that the bending moment or the shear or the torsion should not exceed the capacity or the resistance of the material or the member. And obviously, there must be some factor of safety between the resistance and the demand. Okay. The second is the serviceability limit state. Serviceability limit state means that you should avoid cracking, deflection, buckling, and stability. And there are some third type of limit state is the special limit state. A special limit state, you have to consider we know that the life of a building is 50 years. In 50-year time, it should be able to resist any explosion, loads which are caused by earthquakes or wind loads. So these are called the special limit states. Okay. Now, special limit states are costly. Like, for example, if you want to satisfy the special limit state, that your building should satisfy the special limit state, it will make your structure costly. Okay. It's not economical to go for this limit state. But in areas where you have experienced earthquakes regularly, you have to satisfy this limit state. Okay. So as I told you that what should be the aim of the structural engineer for the design of steel structure, that you should use lighter structure. Okay. This will make your structure economical. And the other factor is that the labor cost for steel structure is very high. You have to consider it. Okay. While you are deciding about your where you want to build that structure. Okay. So in this slide, the abstract of this slide is that you should do economical design. Okay. And you should steel. Okay. Because steel is very costly. Okay. Okay. Now any questions so far?
सर एक जनरल क्वेश्चन है
जी
सर, जैसे हमारे पास कंक्रीट में सल्फाइड और क्लोराइड अटैक होते हैं ना, तो स्टील स्ट्रक्चर को रस्टिंग के अलावा क्या क्या अटैक्स उसके अलावा सर?
Steel is देखिए, first is that, like, for example, you have constructed a building which is made of reinforced concrete. For example, your beam has failed. What you are going to do? You are going for a retrofitting technique. Okay. In steel, if your member is failed, what will happen? You will just unbolt the member and you will place the new member. Okay. First thing. The second thing is that once you want to construct a building which is made out of concrete, okay, concrete structure. So you are going to place the formwork, then you have to come and you have to place the steel, and then you will pour the concrete. Okay, it takes a lot of time. So the speed of construction in steel structure is more. Okay, and as compared to concrete, as I told you, that you have already highlighted that in concrete you have that sulfite attack, fluoride attack, alkali silica reaction. Okay, so the durability of steel is more than concrete. The only thing is that it can be susceptible to corrosion. It is susceptible to high temperature fires. If there is a fire which is outbreak in your building, so it will seriously affect the structural members, and they can degrade. It can degrade the strength of your members. Did I answer your question?
Yes, sir.
Okay. Do you want to take a break for 5 minutes?
No, sir.
सर
अच्छा,
लेक्चर खत्म
मैं
कर
1-2 मिनट की ब्रेक ले सकता हूँ, पानी पी सकता हूँ. Just give me a moment.
Yes, sir.
आपको समझ आ रही है वैसे?
Yes, sir.
आपको नींद आई है? नहीं? अच्छा, okay. So the next is the building codes. Okay, as I told you that in this lecture we will talk about building codes, we will talk about specification, and what is the difference between a building code and a specification. Okay, we for design of buildings we need the in steel structure, or for any concrete structure we need a code. Okay, in that code it has the requirements of the design. Okay, building codes are legal document. They are the policy of the government. Like building code is compulsory. It's a compulsion which is set by a government. Okay, now building code is a legal document. Okay, it is always administered by force of law of government. Like it is the policy. Building codes are a part of the policy of the government. Like you see, building code of Pakistan is a policy. It is a disaster risk reduction policy. Like every building that is built in Pakistan should follow or should satisfy the requirements which are mentioned in the building code of Pakistan 2007. So it is compulsory and it is enforced through law. Okay, but one thing the building code does not have is that they do not give you the design procedures. They just give you the design requirements. Okay, now this is all about building code. Building code is a legal document. It is implemented by the force of law or by the government, but it does not have design procedure, but they just have the design requirements for the building, such as structural safety requirement, fire safety requirement, seismic force requirement, plumbing, and ventilation. But they don't give you the design requirements, how to carry out the design. Okay, so in US there were 3 codes, like Uniform Building Code, BORCA, National Building Code, Standard Building Codes. They were practiced in US, but there were some inconsistency among these codes. So in 2003 they have come up with a new code which is called International Building Code. Okay, now International Building Code is the most followed worldwide. Okay, so the most recent version of a building code is International Building Code. Of course, we have some Euro code as well, but in the context of US, so the most recent version of code document is International Building Code. Before that International Building Code, their Uniform Building Code was adopted. Okay, now in Pakistan, the building code of Pakistan has been adopted from Uniform Building Code. Okay, this code. Okay, but now we are trying to adopt the International Building Code. Okay, now this was about that. What is the most recent code of practice nowadays? You should know that that is International Building Code, and there is loading code, that is American Society for Civil Engineering 7, And the title of this code is Minimum Design Loads for Building and Other Structures. Okay, so Americans ASC and IBC are the most updated version of the codes. This is a complete code, but International Building Code uses loads, and for loads it refers to this American Society for Civil Engineering 7 document, which is minimum design loads for buildings and other structures. Okay, now what are these codes? Like the following codes standards are currently being used in US, okay, when this book was published. First is the International Building Code 2018, but nowadays we have its updated version, which is International Building Code 2021. And I am a member of the Pakistan Engineering Council on revision of that building code. So we are adopting that International Building Code 2021. Okay, so this code which we are using, that Building Code of Pakistan 2007, which was adopted from the Uniform Building Code, we are now shifting from Uniform Building Code to International Building Code. Okay, is that clear to you, that what is a building code? Let me come back to the classroom.
Yes, sir.
Okay, any question or comment?
No, sir.
Okay. Okay. As we discussed that in building code, we just have the design requirements. We do not have the design procedures. And if we want to if we want to have the details on design procedures, we have to consult some specification. Okay, now these design specification represents good engineering practice based on latest research. Okay, so these specifications are published by non-profit organizations such as AISC. Okay, now this AI specification contains the design procedure. The building code does not contain the design procedures, they just contain the design requirement. Okay, so we would need a design specification. Okay, now these design specifications are published by some non-profit organizations like AISC, H2LRFD. Okay, so these design specifications have no legal understanding, but you can adopt it in your policy. Like for example, the government can adopt it. Okay, they can force it that you would use this specification. Okay, what is the example of specification for the case of concrete design, concrete structure design? Do you have an idea? Any idea? कौन सी स्पेसिफिकेशन हम यूज करते हैं फॉर कंक्रीट स्ट्रक्चरल डिजाइन?
सर ACI
इस्तेमाल करते हैं. ओके, इन द कंक्रीट वी यूज ACI, अमेरिकन कंक्रीट इंस्टीट्यूट specifications. They have equations. Okay, when you see that in your book, so this equation is coming from ACI. Okay, 318. Similarly, in steel, we will use American AISC, American Institute of Steel Construction specifications. Okay, so they contain important equations. Okay, which you can use for the design of your structures. So what are the different specifications? Like we, as I discussed, that we are going to use the American Institute of Steel Construction specification. So this specification provides the design of steel structure buildings and their connections. So this is of our concern, that in our course we will study design of structural steel members of a building and their connection. So we will extensively use this AISC. Okay, so where is that pen? Let me go back. Okay, I cannot find that pen. Okay, just give me a moment. Okay, yeah. So we will use this specification, which is AISC. Okay, we will use its 12th edition. Okay. Okay, this is okay. So if you want to design steel structures regarding for a bridge, so you can consult this specification, which is ASHTO. Okay. Now, ASHTO stands for American Association of State Highway and Transportation Officials. Okay, so it covers the design of highway bridges and related structures. For example, you want to design a railway bridge or related structure, you have to consult another specification which we call ARIMA. ARIMA stands for American Railway Engineering and Maintenance of Way Association. Okay, it was formerly known by American Railway Engineering Association specification. Now its name has been changed from ARIA to ARIMA. Okay, then we have another specification which is used for cold, just I'm sorry for that, which is used for cold rolled sections. Okay, so this is specification deals with the cold from steel, which is discussed. Okay, we will discuss the what is the difference between cold roll sections and hot roll sections. Okay, so these are the two types of sections. Okay, so we will discuss them. Okay, so ACI is for hot roll. This is for hot rolled steel sections. Okay, okay. Now we discussed that we will use steel. Okay, now what is a steel? Steel is an alloy of iron and some different material. Okay, steel is not naturally occurring material. It is derived from iron while mixing it with carbon and other elements which include chromium, vanadium, copper, manganese. Okay, so this is an alloy. Okay, now alloy is what is an alloy? Alloy is a homogeneous mixture of two or more elements, and in most of the cases in steel you will find iron and carbon. Okay, so carbon, if you add carbon into iron, it will increase the strength of this mixture which we call steel. Okay, any idea from where iron is derived? Where iron is derived from? What is the source of iron?
Sir, ores.
Earth.
What is the name of those ores? What are their names?
सर फॉरगॉट इट सर, जियोलॉजी में पढ़ा था.
They are hematite, magnetite. Okay, so iron is derived or obtained from an ore which are called hematite or hematite or magnetite. Okay, these are two of the ores from which iron is derived. That iron is mixed with carbon, that iron is mixed with carbon, combination of carbon, manganese, vanadium. Okay, so to produce steel. Okay, steel is an alloy, it is a not a naturally occurring material. Okay, now when was the steel used? Steel was used in the late 19th century, and the first bridge which was constructed out of steel was Aids Bridge, which was constructed in 1874 in St. Louis, Missouri in US. The first building which was constructed from steel was in 1884, and the name of that building was the Home Insurance Building. Okay, which was constructed or completed in Chicago, USA. Okay, So this is the picture of that bridge, okay? The first bridge which was constructed using structural steel. This is some of the colorful picture of that bridge, okay? Its bridge. Then this is the picture of that home insurance building in Chicago, US, okay? So now we will come to the types of steel. Basically, we can classify broadly steel into three categories, okay? Now these categories are the plain carbon steel. In the plain carbon steel, you just have iron and carbon is less than 1%, okay? If this is the composition of the steel, so we will call it plain carbon steel or mild steel. Okay, so mostly we will be using this mild steel. Okay, mild steel. Okay, it has been designated a special name, okay, which is designated by ASTM. We call them A36 steel. Okay, okay, if you mix iron and carbon and plus some other elements, so we call it, where is that mouse cursor, my cursor, we call it low alloy steel. Okay, we have plain carbon steel, we have low alloy steel. In low alloy steel, iron and carbon, apart from carbon and iron, we have some other components, and those components are less than 5%. Okay, when you add more components or elements in the steel, the strength of the steel is enhanced, but at the same time, the reduction in there will be reduction in the ductility of this material. So you are enhancing steel strength or yield strength or the ultimate strength, but at the same time there will be reduction in the ductility of that material. Okay, the plain carbon steel will have more ductility compared to low alloy steel. If you further enhance, like there is a third category we call high alloy steels. Okay, this is similar in composition to the low alloy steel, but with a higher percentage of components added to iron and carbon. These steels are higher in strength than the plain carbon steel and also have some special quality such as resistance to corrosion. Okay, now these are the three types of steel, okay, like three category of steel. So now these steels have been designated different names, okay, and there is an organization we call American Society for Testing Material which designates structural steel. Okay, and one of the most commonly used structural steel is the mild steel, okay, which is designated as ASTM A36 steel, or simply in short we can call it A36. Okay, so we will discuss its stress strain curve, its behavior, which I will show in the next slide. Okay, basically A36, the strength properties are that it has a yield strength of 36 ksi, and the tensile strength of this A36 is 58 ksi, and it varies from 58 to 80 ksi. Okay, now important thing you should note that the structural steel is designated by some specific nomenclature, and this nomenclature is given by ASTM, and the most commonly used steel is A36 or ASTM A36. So we will be using this steel for our for most of the design of our components in this course. Okay, now apart from A36 we have other steels, other grades which are designated as ASTM A572 grade 50. Okay, and we have ASTM A992. So these two steels are very similar in both tensile properties and chemical composition, with a maximum carbon content of 0.23%. Okay, so you will see a comparison between these three steel, like A36 steel. What is the yield point, the minimum yield point? What is the tensile strength? How long, how much is the ductility or the elongation in this steel? And similarly, you can see that A572, and they have some 50 ksi as a yield strength and 65 as their uh, tensile or tensile strength. Okay, so apart from A36, we have also have different structural steel which you can use for in your design. Okay, can we take a break for 5 minutes? You can think of some questions in your mind, so I will get a glass of water for myself.
Okay, sir.
Okay. Okay, I'm back. Any question or any comment from your side? Do you understand what we have been discussing in this class? Okay, it's a very, these are very preliminary things. Okay, I know that. आप लोगों को समझ आ रही है?
Yes, sir.
Like what is the difference between a building code and specification? ठीक है? Which specification we are going to use? What is a design process? Okay. So this is an introductory class, but we have to go through these contents. Okay.
Excuse me, sir.
Yes, please.
Sir, स्टील को हम लोग नेचुरल हैजर्ड से कैसे बचा सकते हैं? लेट्स से एक बड़ा स्ट्रक्चर हम खड़ा कर रहे हैं, थंडरस्टॉर्म से और इन चीजों से कैसे बचा सकते हैं? वही प्रोसीजर है जो बिल्डिंग के लिए हम करते हैं।
जो बिल्डिंग के लिए आपका प्रोसीजर है, बट इन कन्वेंशनल कंक्रीट डिजाइन आप FC प्राइम कितना यूज कर रहे थे? व्हाट वाज द कंप्रेसिव स्ट्रेंथ?
3000 सर।
स्टील में आपको कितना मिल रहा है?
स्टील में
A36 का यील्ड कितना है?
36,000
Yeah.
psi.
This is the difference between concrete and steel. Okay, now we have discussed that A36 or the mild steel will be of our concern. So we will try to look at its behavior, and the behavior of A36 steel we can visualize it, or we can uh, comment about it by looking at its stress strain curve. Okay, so the characteristics of the steel which are of most interest, which can be examined by plotting the results of a tensile test. Okay, the behavior of mild steel or the stress strain behavior of a mild steel can be examined by looking at a simple bar which is subjected to axial tensile loading. Okay, so in this slide you will be seeing a steel bar which is subjected to an axial load. Okay, the intensity of that load is P. Okay, and the axial tensile stresses which are generated, or the load effects which are produced in this member is designated by F, and the entire magnitude of this F can be computed by this formulation by dividing this P by its cross-sectional area, and its cross-sectional area is A. Okay, when you keep on applying that axial load, it will produce some elongation or deformation in this bar, and let's consider that deformation as delta L. And if you want to calculate that strain, so you can compute it by taking a ratio between the change in length by the total length. So this we designate as strain, okay, by this epsilon. Okay, now the terms of all the terms have been explained, so you have to plot this stress versus strain. Okay, now when you plot that stress versus strain, so you will see different curve, a non-linear curve which consists of different plateaus. Okay, first you will see that, let me grab my writing pad. Okay, yes. Okay, now first you will see that there is a linear portion. Okay, when you apply the load and you plot the stress versus strain, sorry, so you will see this linear plateau or linear portion of stress strain curve. We call this linear portion as elastic range, and in elastic range it is up to this limit, and before that there is another limit we call proportional limit. Okay, once we cross the elastic limit, we go into the plastic range. Okay, and this plastic range is from here to here, and the first point on this in plastic range is the upper yield, and the second point is the lower yield. Okay, so in this portion you will see that there is an increase in the strain without increase in the stress. Okay, so this portion or this plateau of stress strain or behavior of mild steel we designate as, oh my god, plastic range. And after that we have a plateau. You will see that the bar will again start taking the load, and up to a point it will take the maximum load. So this portion or this phenomena, when the bar starts taking the load after there is a significant increase in the strain without increase in the load, it again starts taking the load. There is increase in the stress with increase in the strain, and this portion or this plateau we call strain hardening. Then you will see that there is some reduction in the cross-sectional area of the bar. We call that necking or failure, and there is a point which is at which this bar ruptures. Okay, now this is the whole story of this axial loaded bar. First, it behaves in elastically. If we unload the load in the elastic range, it will go back to its original shape. Okay, but if we are in this non-linear range and we unload it, like where is the pen? Let me grab that. If I'm in this range and I unload this member, steel member, so there will be some permanent deformation in this bar. But if I'm in this range, there will be no residual or permanent deformation. Okay, so this is the nomenclature or the behavior of mild steel under tension. Okay, so it behaves in elastic manner, it behaves in a plastic manner. Then there is a region we have in which we have the strain hardening, and there is a point which is called the strength or ultimate strength of the material. So this ultimate strength is of our concern, and we will use this ultimate strength in our design. Okay, and this yield point, okay, upper yield point and lower yield point we are going to use in our design. So there is always an upper and lower point. Okay, but for simplification, this curve you always see this type of curve. Okay, now upper and lower points are like they are merged together, and at this point we call this as yield strength or yield stress of the material. And for A3060, this Fy is 36 ksi. We have seen that. Okay. Okay. Now this point is the ultimate strength. Okay. Now this for A36 steel, it is sometimes taken 58, but it varies from 58 to 80 ksi. Okay. Okay, when we do the steel structure design, you will see that we will make use of these two properties. Okay, Fy and Fu. Okay, and of course this is for mild steel. Okay, low carbon steel. Okay, in ASTM it is designated as A36 steel, and most of the members, because we want to make our member ductile failure, we prefer ductile failure, so we will use this steel for our design of beams, columns, and mostly the demonstration examples you will be seeing in this course will be using this material. Okay, now there is another terminology which is called ductility. Okay, now ductility is related with the elongation, and this elongation is that once you have the final length of the bar, and if you subtract the initial length of the bar from the final and you divide it by the initial length, so this is we call the elongation, and elongation can be related to ductility, so we call it ductility as well. So steel ductility can be measured by elongation, and elongation is computed by this formulation. Okay, okay, now we have already seen the idealized version of this stress strain curve, like, and we know that in this elastic range, if we take ratio of this stress, okay, by this strain, let me die F9, the ratio of stress to strain, this is modulus of elasticity, and its value is for same for all the materials. Okay, so all steel material, 29,000 ksi, and you can take any ratio of stress strain in this curve. Okay, this value, or you can take this value or this value, so it should give you the same number. Okay, so this we call the modulus of elasticity. So now, as you see, you have seen that on the stress strain curve in the elastic range, like here, we had 2 points. Okay,
elastic limit and proportional limit. Okay, so proportional limit is also the elastic, it also represents the elastic range, but it is a, now the material from proportional limit is in the transition zone. Okay, so it is transforming or into a non-linear material. So that's why there are two boundaries, like the proportional limit and elastic limit is mentioned here. So you will see the proportional limit. What is the proportional limit on stress strain curve? Like the stress and strain are proportional. This is completely valid for the elastic range and elastic range as well, elastic limit. The material is said to follow the Hooke's law. If both in the proportional limit and both in the elastic limit, Hooke's law is valid. So there is another point we call yield point. Okay, yield point is the point at which the material will have appreciable increase in the deformation without appreciable increase in the load. Like there will be a slightly more deformation, like there will be a load but the deformation will suddenly increase. Now if you see that, if you come across that point, so you should make sure that that is a yield point. Okay, what there is an ultimate point. The ultimate strength point of the material is the maximum stress that a material can bear before any failure. And if I go back there, so it is ultimate point. This is the ultimate point. Okay, this is the maximum strength. It represents the maximum strength, and this Fy here, it represents the yield strength. Okay. Now there are some definitions of different terms we use. What we call rupture point, the point on the stress strain curve at which material fails or fractures. That point is rupture point. Okay, when we go back to this stress strain curve, so this is the rupture point, but we ignore this point. Okay, we take ultimate strength. We do not use that rupture strength. Okay. So this part is discarded. Okay, starting from here to here. Let me try cross. Okay, up to where we use this one. So what is the engineering stress? We know that if I come back to this same figure, and if we see F is a stress, and if we use the original cross-sectional area of the bar, we call this computed stress as, okay, strain. Where is that? Yes, engineering stress. In the computation of the stress, if the original area or the initial area of the bar of the material is used, we call it as engineering stress. Strain obtained, the strain obtained by using original length of the material in the calculation, we call it engineering strain. But if we use cross-sectional area, we know that when the load is applied to the area of the member keeps on reducing. It keeps on reducing due to the Poissonian effect. And if in the computation of stress, if we do not use the original initial area and we use the area at that very particular moment, we call that stress as true stress. And if we do not use the original length for the computation of the strain, and we use the length which has been there, like when we apply the load and the length keeps increasing, if we use that length in computation of the strain, we call it true strain. So there is a difference between engineering stress and true stress, and there is a difference between engineering strain and true strain. So elastic region, like it's the region in which the material obeys the Hooke's law. In this region, the stress and strain varies proportionally. Like if the stress is increased, strain is also increased. Up to this stress, the specimen can be unloaded without any permanent. There will be not any permanent deformation in your member. Okay, if you want to upload it. The plastic region, the constant stress region where the specimen elongates without any change in load. Like without increasing the load, there will be increase in the strain. Okay. There is a phenomena when the material again starts taking the load, or there will be stress in the material, like here, from here. This from here to here, this plateau we call strain hardening. Okay. Strain hardening, occurs at a strain of approximately 12 times the strain at yield. Okay, the strain, if the strain, it is usually 12 times the strain at the yield. Okay, so this, we enter into that plateau. Okay, so necking, what is necking? Necking is the reduction in the area of the bar. Okay, when there is a pronounced reduction in the cross-sectional area of the bar, so we call that necking. So when does the necking occurs? It occurs at the maximum value of stress, when the specimen begin to neck down. The stress decrease with increased strain and the fracture occurs. Okay, so it is referring to this region. Okay, when there is a decrease in the stress with increase and the strain, and at the same time the cross-sectional area starts reducing at a very fast pace. Okay, so the other definition of ductility, we know that we have already discussed that what we call ductility. Like ductility is the ability of the material to undergo significant plastic deformation before fracturing. Okay, now the stress strain curve shown in the previous slide of typical ductile behavior, which is a capacity of the ductility, can be computed by this formulation. Okay, so what is modulus of elasticity? Modulus of elasticity is the ratio between the stress and strain in the elastic range. The toughness is the ability of the material to absorb energy. Okay, resilience is the capacity to absorb the energy in the elastic range. So there is a difference between the resilience and toughness. Okay, so there is another property we call brittleness. Okay, it is the property of the material that fractures when subjected to stress. Okay, without any post yield deformation or without any warning. Okay, it ruptures. So this is called brittleness. Okay, so at this point I'm going to stop and we can take a break. Okay, is that okay?
Yes, sir.
आप लोग सो तो नहीं गए यार?
No, sir.
आप लोगों को समझ आ रही है?
Yes, sir.
अच्छा, so it's 9:24. So we will be meeting at 9:40. Is that okay?
9:45, sir.
Okay, 9:45 we will meet. Okay.
Okay, sir.
Okay, have a cup of tea. Okay. Okay.